All right, so day 2 of our rationals unit. So today we're going to be talking about adding and subtracting rationals. Okay, we've already reviewed adding and subtracting fractions. And if you remember, these are the picky people. Okay, these are the people who are looking for that one characteristic when it comes to their other partner, and that is having that common denominator. Okay, so if you are adding or subtracting two rationals that don't have the same common denominator, you need to make them the same. Okay, and then once they are the same, you can combine the numerators, keep that denominator, and then simplify if possible. So it's just the same rules as fractions, but we're just going to be adding in our variables here. The same rules as just the plain old numbers, but we're adding in our variables. Okay, so again, when adding and subtracting rationals, these people are picky, have to have the same denominator. Okay, so here's my first problem. We're going to be skipping around a little bit, so follow along with me here. Number 4, we got 1 over 12a minus 3 minus 16a squared over 12a minus 3. Okay, so first thing I notice right off the bat, this is love at first sight. I love to see it, okay? They have the same denominator. Okay, one thing I do notice here, though, that I want to go ahead and take care of just because it makes my life a whole lot easier, is that both of those denominators can be factored, okay, which is what we're going to do first things first. We're going to factor everything that we can. So if I look, numerator number 1 is just a 1. That can't be factored. 16a squared, that can't be factored. But both of those denominators are the exact same. I know that I can take out a GCF, which is 3. And then I'm left with 4a minus 1. Okay, both of those denominators become that because they're the same. So those are my two new fractions here. Okay, and because they have the same denominator, I can just go ahead and keep it. Perfect, love it, easy, easy peasy. And then I just want to go ahead and subtract my numerators. Well, I see that those are not like terms, 1 minus 16a squared. So I'm just going to leave it like that. Okay, but again, we factor everything. So we just factored the denominator, that's taken care of. But now I want to look at this numerator here. Can this be factored? 1 minus 16a squared. If you think about it, okay, there's no GCF, so we're good there. But then I notice it's two terms. I always look at that variable. I see the letter A with a 2 on it. Okay, I know that there's one pattern I need to check for then, dealing with squares, and that is difference of squares. Okay, so I've got to have a variable that is a square. I need two terms that are perfect squares. I know 1 and 16 are both perfect squares, and I need a subtraction sign. I have all those things, so I can do difference of squares here. I just need to square root each term to find a and b. So the square root of 1 is just 1. The square root of 16a squared is 4a. So I know that that numerator is going to become 1 plus 4a times 1 minus 4a. You could have also switched the order of those two parentheses, which is fine. And then on bottom, I still have 3 times 4a plus 1. Okay? And now this is at the point where we look and we see if we have anything that will cancel. Well, I notice here, I do have 2 of the exact same binomial. That's what we can cancel. We know that from day 1 when we simplified. 1 plus 4a and 4a plus 1, that is the same thing, okay? So we can cancel those off, and we're left with 1 minus 4a over 3. Perfect. All done. That is my final answer. Okay? Moving right along. Number 2. Okay, I want you to pause the video right here, and I want you to try this one. Okay, so hopefully what you noticed here, same denominator, okay, which is perfect. That's what I want, okay? So I'm going to go ahead and factor that denominator. When I do that, I should have done the x method, okay? And when you do that, you should end up with n plus 3 and minus 2. Okay, same thing for the second one. makes my life easy. So I know that is my denominator. And I can go ahead and just subtract going across. So n squared plus 3n minus 7 minus n plus 1. Okay? Notice that subtraction sign there. Okay? That means we are subtracting this whole thing. So that means that that negative needs to be distributed out. Okay? So we're left with n squared plus 3n minus 7 minus n minus 1 on top. Okay? So if you messed up anywhere there, go ahead and fix that now. Now we know we need to combine like terms up there because that's not simplified. Okay, n squared doesn't have anybody to combine with. It's fine. We know that 3n and negative 1n makes 2n. And negative 7 and negative 1 make a negative 8. Okay, but we know, like everything else, we have to factor everything. The bottom's already factored, so that's good. But we look at the top, we know we can do X method there. Okay, and when you do that, you're going to end up with n plus 4, n minus 2. Again, I'm not drawing out the X method because we should be pros at that by now. But if you have a question on that, please ask somebody around you. And then last but not least, we do our simplification. So again, binomials, they can only leave the island if they have an exact match. So n minus 2's get to leave, and we're left with just our answer of n plus 4 over n plus 3. Okay, awesome deal. Next up, number 7, another subtraction problem, okay? But this one's different. This one's not like the others. And the reason that it's not is because we don't have the same denominator. And we know we have to have it, okay? So just like when we just dealt with fractions that just had numerical denominators, just a number, okay? We've got to find a number that both of these denominators will go into, or a term that both of these numbers will go into, okay? So if I look, I've got a 2x, which is a monomial term, and I have a 3x, which is also a monomial term. Okay, so I need one big monomial that is going to be big enough for both of these to go into. Okay, so we'll start with the numbers 2 and 3. We know those both go into 6. Okay, so I'm going to go ahead and make 6 a part of my denominator. And then they both have an x. So we don't need to make that any bigger. Just an x to the first is going to be enough for us. Okay, so 6x is going to be that common denominator. We're still subtracting. Now we need to figure out, what do you multiply by to get from 2x to 6x? Well, if you think about it, all you had to multiply by is just 3. So we're going to do that on top too. 15 times 3 is just 45. Okay, and then we're doing the same thing for the second one. But to get from 3x to 6x, what do you need to multiply by? It's not going to be 3. This time it's actually going to be 2. Okay, so what we want to do there is just to, whoops, let me fix that. We just want to multiply by 2. And when we do that on top, 16 times 2 is going to be 32. Perfect. And now this one's pretty easy. We've got the same denominator now. We keep it and we subtract those numerators. And they're like terms, so that makes my life so easy, right? Okay, so this just ends up being 13 over 6x, and that cannot simplify because 13 over 6 does not simplify. So we'll leave it like that. Okay, good deal. Okay, I want you to pause here, and I want you to try number 8 on your own. Okay, so just like number 7, we see here, monomial, monomial, perfect. Okay, those are pretty easy, right? We just need one monomial term that both of those are going to go into. So a squared and 8a. So this is actually a 1a squared, right? We don't necessarily need to write that, but if you did, perfect. So we start with just the numbers 1 and 8. Well, both of those will go into 8. So we'll need an 8 in our common denominator. And then we have a squared and a. Well, if we have 1a has 2, the other one just has 1, we know that we need a squared in order for both of them to be able to go in, okay? If you did something bigger, that's fine. You're just going to have to simplify at the end a little bit more, okay? A squared is big enough for a squared and a to both go into. So if you did a to the third, though, you're not wrong. You'll just have an extra step at the end, so just hold tight and see if you get the same thing as us, okay? Same thing as before. To get from 1a squared to 8a squared, all I need to multiply by is 8. So we'll do that. 4a times 8 is 32a. Hopefully we got that. We're still subtracting here. And then to get from 8a to 8a squared, the only thing I'm missing is just an a to the first, right? It's the only thing I need to multiply by. So I'm going to do the same thing on top. And I get 7a. Perfect. Okay. And now what we're doing is we're just going to keep that same denominator. Perfect, because it's the same. And now we're going to subtract going across 32a and negative 7a. Those are like terms, so we'll keep it. Okay, and then we look, can we do any simplifying here at the end? We always check for that. Okay, we always check for that. So if I look here, 25 over 8, that can't be simplified. But a over a squared, we know that those are the same variable, and we are allowed to simplify those. So if we have 1 on top and 2 on bottom, 1 minus 2 is going to give me a negative 1, which means that a to the first needs to stay on the bottom. So this is going to end up being 25 over 8a. And that is my answer. Okay, so if you got that one, pat yourself on the back. But if you didn't get that one, that's okay. We are just practicing. But be sure to ask questions if you have them, and we will keep moving forward. Next problem here, we've got number 10. Okay, this looks a little complicated, right? Not like the other one that we dealt with at all. These are much bigger. They're not monomial terms. Okay, we noticed the first one's got 2 terms in that denominator. The second one's got 3, and that's totally fine, okay? But we know that they're not the same, and we know that we need to factor them if possible. So y plus 8 is my first one. That can't be factored. That's just done, okay? But y squared plus 11y plus 24 absolutely can be factored. We'll go ahead and do the whole x method just for those of us who want a little refresher on that. So we draw our x. On the top, we need 24 because 1 times 24 is 24. On the bottom, 11, 2 things that will multiply to 24 and add to 11 are going to give me 8 and 3. Okay? One little shortcut that some classes know, some might not know yet. Anytime that the a value in the front is a 1, these and their signs are just going to be, these numbers on the sides of my x, they're just going to be the actual factors that we use. So here we have a plus 8 and a plus 3. So this is just going to become y plus 8, y plus 3. If you want to do all the work of factor by grouping to get those out, you can. But this is just a shortcut that you can use. But again, it only works when a equals 1. Okay? So there are my factors. So that's my new denominator there. It equals the same thing. Okay? And now we see that I'm dealing with, again, a binomial and then 2 binomials for my second denominator. So again, I need a denominator that both of these will go into, a common denominator. So what I want to do, anytime I'm dealing, once I've factored the denominators and I'm dealing with binomials, I like to use a color code, okay? So what I want to do is just highlight or color or use colored pens, whatever you have, and color the ones that are the same. So if we look, we have 2y plus 8 in each of those denominators. So that is a common binomial. And then we also have a y plus 3. Okay, first one didn't have a y plus 3. The second one did. So when dealing with finding a common denominator, I need to have every color represented that I have. Okay, so if I look, y plus 8 Definitely going to need that, okay, because it's in both. I also need that y plus 3 in my common denominator, okay? So we need that for both fractions. And we'll go ahead and we'll keep with our colors here. If you brought highlighters, great. If not, borrow from a friend here. Okay, so we have our common denominator now, and now we're just gonna look at those individual fractions and see what do I need to multiply by to get to that common denominator, okay? So if we look here, the first fraction, 7 over y plus 8. So to get from y plus 8 to y plus 8 times y plus 3, what am I missing there? If I look, I already got the blue. I'm missing the green here, whatever colors you use. I'm missing that y plus 3. That's what I need to multiply both the top and the bottom by. So that's what I'm going to do. So times y plus 3 and times y plus 3. We'll put it in parentheses there. Okay, so on top here, I have 7 times y plus 3. Okay. Now on the second one, y plus 8 to y plus 3, to get from there to there, I already have both, right? I already have both of those binomials represented in that denominator. So I actually don't need to do anything. I'll just keep that 35. Perfect. And now I have the same denominator, which makes my life easy. Okay, we know we can combine these two things. And now I just need to add my terms going across. I'm going to go ahead and distribute. So this becomes 7y plus 21 plus 35. So 7y plus, what is 21 plus 35? We got 56. Perfect. And we're almost done, but again, everything has to be as factored as possible. Okay, so 7y plus 56, can that be factored any further? Yes, I can take a GCF out on top. And when I do that, I get 7 times y plus 8 over y plus 8, y plus 3. And now we look, can any binomials leave this island? And yes, y plus 8s are on the top and the bottom, so we'll get rid of them. And we're left with 7 over y plus 3. That is my final answer there. Okay, so this is a process. This is a definite process. Hopefully this is making sense, though. We're going to keep practicing, so hold tight. Next problem, number 11. Okay, I want you to pause here. I want you to try this one. Work with your group and see if you can figure this one out. Okay, so very, very similar to the last one. Okay, so when we look here, we see both denominators do not equal the same thing. One's a trinomial, one's a binomial. Okay, we could go ahead and pick a color for that binomial. Any color you want, if you're color coding. If not, just watch me. Okay, so we got x plus 2, and then we need to factor that other denominator to see what binomials are going to be represented. So hopefully you did x method. It's the only way to do this, and you should have got y plus 2, y plus 3 as that denominator. Okay, and then we notice right off the bat, hey, I already had an x plus 2. I color coded that, so we'll keep it. And now we're going to color code that other binomial, which is x plus 3. Perfect. And now to find the common denominator. So both of them have x plus 2 already. And in order for this to be a common denominator, they both need x plus 3 as well. Perfect. Perfect, perfect. Love to see it, okay? First fraction now. To get from x plus 2, x plus 3 is my denominator, to x plus 2, x plus 3 is my denominator. I don't need to do anything, okay? That's already done for me. X squared minus 5, we'll keep it. And then the second one, to get from x plus 2 to x plus 2 times x plus 3, pretty obvious there. We got to just multiply by x plus 3. That's the only thing we're missing. So we're going to multiply by x plus 3. on top and on bottom. 1 times x plus 3 is just x plus 3. Okay, and we're still adding here. Now we have the same denominator. We love to see it. And we're adding straight across. So we're combining like terms if we have them. Looks like we have x squared. That doesn't have any like terms. We have an x, no like terms. And then -5 and 3 are like terms. -5 plus 3 is -2. And then just like the previous problem, factor, 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 everything. So the bottom is already factored for me. Perfection. Okay, the top is not. We gotta do X method again. Okay. And when we do that, we are going to end up with x plus 2, x minus 1. Do we have anybody leaving this island? Yes, we do. And our final answer is x minus 1 over x plus 3. Okay, so take a minute, make sure you have that down. Okay, cool. We are going to keep moving forward. Number 13. Okay, so this one's a little bit different. Okay, we see that we have 2 different binomials as my 2 different denominators, okay? Meaning that they're already factored, right? So there's no factoring here that I have to do. I can't do anything to w plus 1 or to w minus 7. But those aren't the same denominator. We have to have a common denominator here. And back to the whole color coding thing, just that helps me to kind of visualize this. I'm gonna make one of them one color, and I'll make one of them the other color, okay? And again, anytime we're making a common denominator, we have to have every single color represented. So I need w plus 1, and I need w minus 7. Okay, so when we do this now, we'll keep those colors there. Okay, when we do this now, again, same process as before. We need to see what are we missing, okay? So in that first fraction, 5 over w plus 1, I have w plus 1 already in that denominator, okay? So I don't need to multiply by that. I just need to multiply by what's missing, which is the w minus 7. Okay, so I'll multiply by that on the bottom and the top. So 5 times w minus 7, sorry. There we go. We'll distribute that out. Go ahead and just do that to get 5w minus 35. Perfect. Okay, and then we move along to the second one. What are we missing there? Okay, I want you to pause the video here and see if you can work this problem from there. Because I think you're going to be able to see that it works pretty similar to the previous one, just a little bit different. So pause here, finish this one up. Okay, so hopefully on that second fraction there, you notice we're missing the w plus 1, okay? So that's what we need to multiply both the top and the bottom by. When we do that, we get 8w plus 8 when we distribute that out, okay? And then we are combining like terms on the top. So 5w and 8w are the same, or like terms, I mean. So that becomes 13w. Negative 35 and plus 8 becomes minus 27. And then we keep the denominator. Okay. From here, this is where we would see, can we factor that numerator if possible? And 13 and negative 27, no. There's nothing we can do there. Okay. So we're actually just done. This is the final answer. It's not super beautiful, but that's part of Algebra 2. We know that not all of our answers are going to be stunning, okay? But that is it. Okay. Last problem we're going to do today, similar to the last one, to number 13, in that we do have 2 different things going on here. But we do notice that one's a binomial, one's a monomial, okay? Those are 2 different things, right? We can never make a monomial into a binomial, okay? When it comes to these kind of problems. So what we need to do, we'll stick with the color coding, okay? We got a b plus 3 And we have a b, so plain old b. So to find a common denominator, okay, we need a monomial term that all the monomials will go into. So in this case, it's just b. And then we just need all of our binomials represented. So b plus 3. So that is my common denominator. And then we just multiply by what we're missing. So the first fraction, we're just missing the b. So multiply by that on the top and the bottom. On the top, b times b is just b squared. And then for the second one, we're just missing the b plus 3. So that's what we multiply by on the top and the bottom. So when we distribute that out, we get 4b plus 12 on top. But we're subtracting, so we're subtracting that whole numerator. So on the top, we have b squared minus 4b minus 12. On the bottom, b times b plus 3. We look, can we factor that numerator? And if we try the x method, yes, it's going to work. Okay, it's going to end up giving me b minus 6 and b plus 2 over b times b plus 3. Perfect. Can we simplify from there? Are any of those binomials the same? Do we have any monomials to simplify? No. So that's it. Another ugly answer, but that's part of it. So that is just the introduction here to adding and subtracting. We will go over this quite a bit more next class. I know that I'm not there today, so that's why this is in the video format. But please be sure to come see me during one time. Another day this week, obviously not today, but if you have questions, please ask them. You can also message me on Canvas and I can help you out too, and work with a group to complete today's homework assignment. Thanks, guys.